cones. So how many do this squared base pyramid will fit inside of this prism? Now it's got the same height and the same base. So if I fill this with water, turn it around, make it like a cup, how many times can I drop it in here? If we were in class, I would stop it and make a guess. How many of these cones do you think can go inside of this one? It's the same height and the same base. So it's actually exactly the same dimension. How many can you fit? Okay, if I'm in class right now, please stop my video and then get some answers. If not, you're gonna find out that it's 3 times. A little hard to guess that 3 times. Most people would say 2 times, 2 and a little bit, 700 times. But it's exactly 3 times, and I will link a video for you guys to see somebody doing that experiment. Which means that to figure out the volume of a pyramid, of a cone, we just have to figure out the volume of the prism and then divide it by 3. Just divide it by 3. I made that look like a percentage. Divided by 3. That's it. That's all we got to do. So the volume for a square base prism is going to be, well, base times length times width, length times width times height. That's the volume for this, and then I'll just divide it by 3. And here, the volume for the cylinder, it's pi r squared times height, but because I'm doing it for the cone, I'll just divide it by 3. Pretty straightforward. So let's do an example here. Here's a square base prism, and it just kind of goes up. And so let's figure out the volume for the actual prism. So it'll be length times width times height. But we need to divide it by 3. And I can do the divided by, I can put 1/3 in front. So this is 4 by 4 by 9. 4 by 4 by 9. But I need to divide it by 3. And that would be my answer. So 4 times 4 is 16. Times 9 is 144. But now I need to divide it by 3. Divided by 3, it's 48. Exactly 48. And that's 48, in this case, centimeters cubed. That's how much volume is inside in this square base pyramid. And if we're talking about a cone, same kind of idea. Now this would be a cylinder, right? If we're going all the way up. So I'm going to get the volume of the cylinder, which is pi r squared. And then I would now multiply it by the height, which is 18. But then I need to divide it by 3. Because it's not a cylinder, it's a cone. So I'd say pi, the radius, in this case they gave it to me, and that's 8 squared times the height, which is 18. And then I need to divide it by 3. Plug it into the calculator. Pi times 8 squared times 18 divided by 3. 1206.37. I'm going to do 2 decimal places, and that's in centimeters cubed. And that will be the volume of this cone. Notice that in this case they gave us this height. This height right here is called the slant height. And notice that we can make a triangle between the 18, the 8, and this slant height. Sometimes they actually don't give us the height, they give us the slant height. And what we need to do, because this is across the hypotenuse, is figure out what this number is, which in case is 18. So they may give us a cone like this, and they say, oh, the slant height is 10. This is 8, and now we have to figure out what is the height. And we're going to use Pythagoras to figure that out, and we'll do some of those in class for practice.